Hi, hello, vanakkam, and welcome back to Little Slaw YouTube channel. And in this video, we will see about the performance audits. How does this scoring works and how does Lighthouse performance scoring works? So initially, I have told you that there are five different audit available in Lighthouse. One is the performance, which you see here, and then the opportunities. The third one is the diagnostics, and then we have the accessibility, and we have the best practices. So all these, and then again the SEO, which is the main one, which helps the pages for the ranking part. So let's see them one by one. So for this, in this video, we are going to see about the performance audit. So the main concepts of this first contextual paint, how does this work and what is this time to interactive, the speed index, the total blocking time, the largest contentful paint, and cumulative layout shift. So we will see each and every one of them individually. So in this video we're going to discuss only about the performance audits. So in general, these metrics contribute to our Lighthouse performance score, but not the results which we see in the opportunities or the diagnostics make any manipulation to the performance scores. And again, improving the opportunities and diagnostics, like improving the metric values, so there is an indirect relationship between the performance, the opportunities, and the diagnostics. But we will outline why the score fluctuates and how it is compromised and how this Lighthouse scores has evaluate each individual metric. So first let's see, why does the score fluctuates? The score which we see here in the performance, so why does the scores fluctuates? So there is a lot of variability in the overall performance score and metric values, and this is not due to Lighthouse. So when the performance score fluctuates, it's usually because of changes in underlying conditions. So some of the problems like the A to B tests or changes in ads being served, the internet traffic, the network, the traffic that we use during testing, and testing on different devices such as high performance desktop and a low performance low performance laptop. So in some cases where we might be testing the application inside the client's network, or in some cases we will be using a VPN, or in some cases we use a cloud network where we test the performance of the application from a virtual machine. So there are various factors that affect or that fluctuates the score. And then we have the browser extensions which injects JavaScript and which even add or modify any network request. And then finally we have the antivirus software which we have installed in our machine. So all these factors makes or the reasons of the fluctuations of these scores which we see here as part of the performance. Even though Lighthouse provides us a single overall performance score, so here we can see the 70 overall performance score, it might be more useful to think of our site's performance as distribution of scores rather than a single number. So let's see how does this performance score is weighted. So the performance score is the weighted average of the metric scores which we see here. So this performance score, the overall performance score, is the weighted average of the metric scores, and naturally the heavily weighted metrics have a bigger effect on the overall performance score. So not every metric has the equal weightage in calculating the performance, and these metric scores are not visible in the report but are calculated under the hood, which is they are calculated, they have their own set of algorithms to calculate, and these weightings are chosen to provide a balanced representations of the user's perception of performance. And these weightings which we see here have changed over time because the Lighthouse team is regularly doing research and gathering feedback to understand which particular metric has the biggest impact on user perceived performance. So here we could see different metrics like first contextual paint, the time to interactive, the speed index, the total blocking time, largest contentful paint, the cumulative layout shift. So let's see what is the first contentful paint. So here we could see the first contextual paint has 0.4 seconds. So what is a first contextual paint? So this is one of the 6 metrics which is tracked in the performance section of the Lighthouse report. And each metrics captures some aspect of the page load speed. So what does this first contextual paint measures? The first contextual measures how long it takes for the browser to render the first piece of DOM content after a user navigates to the page, and the images and the non-white elements and the SVGs on our page are considered as DOM content. So the images, the non-white elements and the SVGs. So in websites like the retail or in many other pages, we could see a lot of images that gets loaded, and anything inside an iframe is not included. So we have to consider while designing. So this has to be a recommendation. So anything that comes inside an iframe is not included as part of the FCP, that is the first content paint. And so how does Lighthouse determines the FCP score, or the first contextual paint score? So when we see this FCP score is a comparison of our page's FCP time, and the FCP times for real websites are based on the data from HTTP archive. So for example, the sites performing in the 99th percentile render the first contextual paint in about 1.2 seconds, and in case if our website's first contextual paint is 1.2 seconds, our first contextual paint score is 99. So here we could see it is around 0.4 seconds, which means the FCP score is 99. And we have a set of interpretations. Say for example, if the FCP time is 0 to 1.8, we could see a green color coding, and in case if it is between 1.8 to 3, we could see an orange color coding, and if it is more than 3, we get a red, so which means it is slow, so red color coding for this. And then how to improve, so after testing, so we have to tell the developers that how to improve the FCP score. So one issue that's particularly important for this first contextual paint is the font load time. So that for font load time has to be concentrated in case if we want to improve the FCP score. And in fact, the fonts are often the large files that take a while to load, and some browsers hide text until the font loads, causing a flash of invisible text. So how does this Lighthouse font display audit fails? So Lighthouse flags any font URLs that may flash invisible text. And how to avoid showing invisible text? So the easiest way to avoid showing invisible text while custom fonts load is to temporarily show a system font. So by including the font display swap in our font face style, we can avoid the flash of invisible text in most modern browsers. And this font display API specifies how a font is displayed, and the swap inside the code tells the browser that the text that is being used in the font should be displayed immediately using a system font rather than the difficult font, the font that has a huge style. So the immediate way of displaying should be the system font, and once the custom font is ready, it replaces the system font, and this way we can get a quick first contextual paint. And even in fact we can preload the web fonts, and even we can use the Google fonts. And for this we have to mention that not all major browsers support font display, and so you may need to do a bit more work to fix the invisible text problem. And next, when it comes to tracking the first contextual paint on real users devices, we have to programmatically access the first contextual paint data and submit it to Google Analytics. So in this way, we can track the FCP on the real user's device and how to improve the overall performance score. So unless we have a specific reason for focusing on a particular metric, it's usually better to focus on improving the overall performance score and using the opportunities section of our Lighthouse report to determine which improvements will have the most value of our page. And in fact, the more significant the opportunity, the greater the effect it will have on our performance score. Say, for example, if the Lighthouse screenshot shows that the estimating render blocking request will eat the biggest improvement, then we will have to fix it. And then when it comes to the speed index, which is the second metric, so this speed index is one of the 6 metrics which is tracked in the performance section of the Lighthouse report, and each metrics capture some aspect of page load speed. So what does this speed index measure? So here we can see it shows how quickly the contents of a pages are visibly populated, and this measures how quick the contents is displayed. So Lighthouse first captures a video of the page loading in the browser and computes the visual progression between frames. And in fact, Lighthouse uses the speedline node.js module to generate the speed index score. And in fact, we can see how this Lighthouse determines the speed index score. So we can see that if the speed index score is between 0 to 3.4, it has a green coding and it is fast. And if it is 3.4 to 5.8, the speed index is orange, which is moderate. And if it is more than 5.8, it is slow, which is red. So here we can see the speed index is around 12.9, and since it is slow, so how to improve the speed index score? So while anything we do to improve the page load speed will improve the speed index score, and addressing any issues discovered by the diagnostics audits should have a particularly big impact. And in fact, we have 3 impacts, which is the minimizing main thread work and reducing the JavaScript execution time and ensuring text remains visible during web font load. So we will see that in a separate video on how to minimize the main thread work and how to reduce the JavaScript execution time and how to ensure the text remains visible during web font load. So let's see how to improve the overall performance score. So unless we have a specific reason for focusing on a particular metrics, it's usually better to focus on improving the overall performance scores. And again, we will have to use the opportunities part. So for example, by eliminating the render blocking resource. Third metric is the largest contentful paint. So this is one of the metrics which is tracked in the performance section, and each metrics captures some aspect of the page load speed. So what does this LCP measure? So this LCP measures that when the largest content element in the viewport is rendered to the screen, and this in fact approximates when the main content of the page is visible to users. And how Lighthouse determines your LCP score? Again, we could see an LCP score of 0.4 seconds, which is the fastest one, which is green. So 0 to 2.5 is green, and 2.5 to 4 seconds is orange, and over than 4 is red, or which is very slow. And then we have the fourth metric, which is the time to interactive. And this time to interactive is important because some sites optimize content visibility at the expense of interactivity, but this again can create a frustrating user experience because when the site appears to be ready, but when the user tries to interact with it, nothing happens. So this time to interactive has to be very quicker, that the user has to be ready or he will be always ready to interact. And what does this TTI measures, the time to interactive? So TTI measures how long it takes for a page to fully interactive, to become fully interactive. A page is considered fully interactive when the page displays some useful content which is measured by the first contextual paint. So this time to interactive is directly connected with the first contentful paint. So the first display or the page that displays the first useful content is measured by the first contentful paint, and any event handlers are registered for most visible page elements, and the page responds to user interactions within 50 milliseconds. So this is very quick, and that has to be the time to interactive. So how does this lighthouse determines our TTI score, that is the time to interactive score. So the time to interactive score is a comparison of our pages time to interact and the time to interact for real websites based on the data from the HTTP archive. So for example, if the site's performing in the 99th percentile, render TTI in about 2.2 seconds, and if our website's TTI is 2.2 seconds, then our TTI score is 99. And again we have this SLA, so anything that comes between 0.30 to 3.8 is green, which is very quick, and here we have this page as within 1.4, and any metric that comes in between 3.9 to 7.3 is orange, and any response over than 7.3 is very slow, or it has the red color coding. And how to improve this TTI score? So one improvement we have is the particularly the big effect on the TTI is deferring or removing unnecessary JavaScript work. So in case if we add more amount of or more number of JavaScript in case of any design or for any client side performance or for any client side actions, we will have to remove any unnecessary JavaScript work. And looking for opportunities to optimize the JavaScript is the main way to improve the time to interactive, and in particularly consider reducing the JavaScript payloads with code splitting and applying the PRPL pattern and optimizing the third-party JavaScript also yields significant improvement for the websites. And in fact, there are two diagnostic audits that are provided for adding additional opportunities to reduce the JavaScript work, something like the minimized main thread work and reducing JavaScript execution time. And then we have the total blocking time. So this total blocking time is another metric which is displayed in milliseconds. So what does this TBT, or the time total blocking time measure? So this total blocking time measures the total amount of time that the page is blocked from responding to user input such as mouse click. So the page, when we are loading the page, but we are not able to respond to any user input, something like a mouse click or a screen tap or any other keyboard process. So until otherwise the page is responsive to the user, we call it as the total blocking time. So once the page gets loaded automatically, it has to be very interactive, something like we see here, the time to interactive. So this total blocking time is the sum of the addition of the blocking portion of all the long tasks between the first contextual paint and the time to interactive. So this total blocking time is the sum of the first contextual paint and the time to interactive. And in fact, any task that executes for more than 50 milliseconds is a long task, and the amount of time after 50 milliseconds is the blocking portion. And for example, if a lighthouse detects a 70 millisecond long tasks, the blocking portion would be 20 milliseconds. So here we could see the total blocking time is around 390 milliseconds. So we can see the blocking portion again will be increased based on that, and again it is in a red color coding. So any blocking time which is between 0 to 200 seconds is green, and any blocking time between 200 to 600 is orange, and any blocking time over 600 is red, or which is slow. And how to improve the total blocking time score? So in general, the most common causes of long tasks are again the JavaScript loading, JavaScript execution. So while analyzing the code in the performance panel, we might discover that the main thread is doing work that is not really necessary to load the page. So again, we will have to reduce the JavaScript payload with code splitting, or by removing any unused code, or even efficiently loading third-party JavaScript. And any inefficient JavaScript statements has to be removed. For example, like after analyzing the code in the performance panel, suppose we see there is a call that returns 2000 nodes. So by refactoring the code will be more useful, and it can even reduce it to 10 nodes, and this will improve the total blocking time score. And finally, we have the cumulative layout shift. So what does this cumulative layout shift tells about? So this is an important, and this is even an user centric metric for measuring the visual stability, because it helps quantify how often user experiences unexpected layout shifts, or a low CLS helps ensure that the page is delightful. So for example, we are reading an article. So here we are reading an article online. So when we see something suddenly changes on the page without warning, the text moves and we have lost our place, or even worse, we are about to tap a link or a button, but in the instance before our finger lands, the link moves and we end up clicking something else. So for example, if we can see here, so we are trying to click on this particular link and something else has come, or automatically it is moved. So this is called as cumulative layout shift. So for example, if I'm clicking on a particular page, and then when I'm trying to click on it, so automatically when something comes in, so this layout gets shifted. So most of the times these kind of experiences are very annoying, and but in some cases they can use, or they can even cause very real damage. And this unexpected movement of page content usually happens because resources are loaded asynchronously, or any DOM elements get dynamically added to the page above existing content. And in fact, the culprit can be an image or a video with unknown dimensions and a font that renders large or smaller than its fallback, or a third party ad or widget that dynamically resizes itself. So what makes this issue even more problematic? So we'll see that. So we can see that there is a site function in the development which is quite often different from how user experiences it. So we can even see that there is a personalized or third party content which is often do not behave the same way in the development as it does in production. And in fact, we have the test images which are already in the developers browser cache, and any API that calls so fast that the delay is not noticeable. And this cumulative layout shift metrics helps us to address this problem by measuring how often it occurs in real users, or for real users. So this cumulative layout shift is a measure of the largest burst of layout shift scores for every unexpected layout shift that occurs during the entire lifespan of a page. And in fact, a layout shift occurs anytime a visible element changes its position from one rendered frame to the next. And in fact, a burst of layout shifts, which we call a session window, is when one or more individual layout shifts occur in rapid succession with less than 1 second in between each shift, and a maximum of 5 seconds for the total window duration. And the largest burst is the session window with the maximum cumulative score of all layout shifts within that window. So what is a good CLS score? Again, we'll have to find the good CLS score. So any CLS score which comes less than zero point 0.1 is a very good CLS. So here in this particular page, we do not find any of the layout shifts here. So this we could get 0, which is the best score, and anything that comes with less than 0.1 is the best one, and anything between 0.1 to 0.5 which needs improvement, and anything more than 0.25 needs more improvement, or it's very poor. So we'll see about this layout shifts in detail in a separate video. So far we saw about the performance metrics. So in our next video, we will see about the opportunities part, and we'll see how to use the opportunities to improve the performance of the application. So until we meet you in another interesting video, it's Baba from Asan Shanmugam and Little's Law.